This is section 10.2, which covers the hyperbola. Here are the objectives. We'll talk about hyperbola centered at the origin and centered at HK. We'll identify the eccentricity and take a look at some applications involving hyperbolas. As mentioned in the previous lesson, the definition of a hyperbola is seen here, and if we take this cone and intersect a plane, well, green is probably not the best color, we end up with this and this. So basically we have two branches of this conic section, and that's what we'll talk about. So as mentioned, the hyperbola consists of the two branches, which are given to us in this blue color here. And the sum of these distances here is a constant, and those are the distance from the foci. So once again, we will have foci. The foci are arranged in between these branches. We will have a transverse axis now, which is this here. So this is the transverse axis. It will be horizontal or vertical. So the hyperbola could also have branches that open up and down. This is a horizontal transverse axis. This is a vertical transverse axis. And we'll look at that here. So first we're going to have hyperbola centered at the origin. Now these equations are going to look very similar to the equations of an ellipse. But one major difference is that A is not necessarily bigger than B. So A can be smaller. So one thing to notice is that we will have a minus sign now. So unlike the ellipse, the hyperbola equation will have a minus sign. Center is the same, but now one thing to pay attention to is which variable is positive. So if x comes before the minus sign, you are going to have a horizontal transverse axis, which means the hyperbola opens right and left. On the other hand, if the y value comes before the minus sign, that means the y value is positive, then you're going to have a vertical transverse axis, which means the hyperbola will open up and down. Sometimes we will have asymptotes in this case, and sometimes we are asked to find the asymptotes. If the hyperbola is centered at the origin, then the asymptotes are found by this equation here. It's basically an equation of a line, and it's plus or minus b divided by a, or a divided by b. So it just kind of depends on the transverse axis. Here is an example of what the graph of these parent functions will look like. Again, the horizontal transverse axis will be opening right and left, where the vertical transverse axis will be opening up and down. And again, the way you tell is by which value x or y is positive. Here are a couple quick examples. The things I want you to notice is that an ellipse has a plus, and depending on which denominator is bigger will help us identify the horizontal or vertical major axis. On the other hand, if we have a minus sign, then we will have a hyperbola, and you want to identify which value is before the minus sign, or which value is positive. If x is positive, horizontal transverse axis as seen below. If y is positive, vertical transverse axis, which is seen below. All right, so this kind of summarizes some things. So I've already talked about these things, these first two bullets. So when you are graphing these, what we're going to do is we're going to first graph a reference rectangle. And once we have this reference rectangle, that will help us draw in our asymptotes. And then we can go ahead and draw in the branches. So you can pause this and read through it, and I'll show you in the next slide how to graph a hyperbola. As you can see in this first example, we're asked to find the very same type of things that we were asked to find when graphing an ellipse. So we'll want to find the center, vertices, foci, and the new thing here is the equations of the asymptotes. So looking at this, I notice that it is an equation of a hyperbola because of the minus sign in between the two fractions. Notice also that this equation is equal to 1. Now looking at this, because I know it's a hyperbola, I want to look at the variables. Because the y value is first, or positive, this tells me that I have a vertical transverse axis, and a squared is 16. If a squared is 16, this tells me a is 4. Well then, b squared is 20, so that tells me that b is the square root of 20, or 2 root 5, and that's approximately 4.5. All right, the center, since I don't have anything attached to the x and the y, the center is 0, 0. So from the center, because I have a vertical transverse axis, that means that my hyperbola is going to open up and open down. So from the center, we are going to go up and down a units. So 4 in this case. All right. So that's going to tell me my vertices. So if I want to give the coordinates of the vertices, I start at the center, and then I'm going to go up and down, which is the y value, 4 units. So 0, 4, and 0, -4 are my vertices. Now, remember, we're going to be making this little reference rectangle, or a little box is what I refer to it often as. So once we have A, then we will do B. So from the center, we're going to go to the right 2 root 5 and to the left 2 root 5, which is really 4.5. Now that I have this, what I'm going to do is I'm just going to lightly sketch in a little box. Once I have this box sketched, then what I'm going to do is sketch my asymptotes. The asymptotes go from corner to corner. So I will have this asymptote and this asymptote. Eventually, I'll want to write the equations of those asymptotes, which I'll do shortly. But now I can actually sketch in the branches of my hyperbola. because I know it's a vertical transverse axis and this is a vertice or a vertex and this is a vertex, I'm just going to follow my asymptotes and sketch in my branches. So here is what my hyperbola will look like. If you want, you can then go ahead and erase the square that you drew in because it's not necessary to keep it. All right, we need to go ahead and address the rest of these items. We have found the vertices, but now we need to find the foci. So to find the foci, I'm going to use the equation c squared is equal to a squared plus b squared. This is one other difference between the ellipse and the hyperbola. And again, it's just the opposite sign. So in our case, we will have 16 plus 20. And I want to point out, in this case, a squared is not bigger than b squared. This is equal to 36. So taking the square root of both sides, I find that c is 6. So from the center, I'm going to go up 6 units and down 6 units. And this will give me my foci. So the foci from the center of 0, 0, we go up and down 6 units. So 0, 6, and 0, negative 6 for the foci. The last thing we need to do is find the asymptotes. Because I have a vertical major axis, I will use the formula y equals plus or minus a divided by bx. Now all this is the equation of this line with a positive slope and this line with a negative slope. And we use a and b to find those slopes. So in this case, it's going to be y equals plus or minus a divided by b. Let's see which, in this case, is 4 divided by 2 root 5 divided by x. And then if I want to rationalize, I could write this as y equals plus or minus 2 root 5 over 5x. And that just represents the two different equations of the asymptotes, one with the positive slope and one with the negative slope. That's it. Okay, so this is the same thing, but now I don't have the standard form of an ellipse, or I'm sorry, of a hyperbola. And so what I want to do, just like the ellipse, I'll divide everything by 16 and simplify if I can. So this gives me the equation y squared divided by 4 minus x squared divided by 16 is equal to 1. Because of this minus sign, I know that I'm dealing with a hyperbola. Because the y value is positive, I know that I'm going to have a vertical transverse axis, which means once again my hyperbola is going to have branches that open up and down. I don't have anything associated with the x and the y in this case, so my center once again is 0, 0. So a squared is always first, so a squared is 4, which means a is 2. B squared is 16, which means b is 4. So from the center, I'm going to go up 2 units and down 2 units because I have a vertical transverse axis. This tells me my vertices are going to be 0 and plus and minus 2. I'm going to use B to help me make my box. So from the center, I'm going to go to the right 4 units and to the left 4 units. Oops, 1, 2, 3, 4. 1, 2, 3, 4. All right, so this helps me make the box. With this box, I'm going to draw in my asymptotes, and those will be from corner to corner. So here and here. And shortly we will write the equations of those asymptotes. But now, because I know I have a vertical transverse axis, I know my vertices are here and here, I can follow my asymptotes and sketch in my branches. If you want, you can go ahead and erase the box. And this is the graph of your hyperbola. So let's go ahead and find my foci. The equation is a squared plus b squared in this case. So 4 plus 16, which is 20. So c is the square root of 20, which reduces to 2 root 5. And that's approximately 4.5. The foci are always in the middle of these hyperbola branches. So from the center, we're going to go up 4.5 units and down 4.5 units from the center. So my foci are going to be, well, we should probably give the exact value. So 0, 2 root 5, and 0, negative 2 root 5 for my foci. Finally, we want to write the equations of the asymptotes. If you can't remember the little formula that's given, all you need to do is use 2 points on each line and find the equation. So y equals plus or minus a divided by b. Because it's a vertical transverse axis, it's the opposite if it's a horizontal transverse axis. This gives me plus and minus 1/2 x. Okay, now of course, depending on what the center is, the asymptotes will change. And that leads me to the next slide, is finding equations of the line centered at HK rather than centered at 0. So if we're centered at HK, really the only thing that's going to change is this. Everything else is the same. So let's see this in action. All right. Looking at this, you want to pay close attention to which value is attached to x. H is always attached to x, and k is always attached to y. So this tells me that my center is 4, negative 3. Remember, it's always the opposite of what you see. So I'm going to go ahead and graph that now. This is my center. Okay. Moving on, I can see that x is first in this case. So x is before the minus sign. This tells me that I have a horizontal transverse axis, which means my hyperbola is going to be opening right and left in this case. So a is always first, so a squared is 9, and that's just for the hyperbola. So a is 3. So from my center, I'm going to go right 3 units and left 3 units. That's going to give me my vertices. So if my center is 4, negative 3, I'm going to move right and left, which is an x value. So I'm going to move right and left 3 units. So 4 plus 3 gives me 7, negative 3. And 4 minus 3 gives me 1, negative 3 for my vertices. I have my center, I have my vertices. I should go ahead and find b to make my box. B squared is 7, so b is the square root of 7. Plugging that into my calculator, it's approximately 2.6. So from my center, I'm going to go up about 2.6 units and down 2.6 units. And all b is used for is to help me make my box and to help me find my foci. Okay, my asymptotes are from corner to corner. But now my transverse axis is horizontal. So this is a vertex and this is a vertex. So I'm going to sketch in my branches this way. Once again, if you want to erase the box, you certainly can. All right, now let's go ahead and find the foci. So c squared is a squared plus b squared. So 9 plus 7, that is 16. So c is 4. So from my center, I'm going to go to the right 4 units, and I'm going to go to the left 4 units. So my foci from the center of 4, negative 3, moving right and left is the x value, and I'm going to move right and left 4 units. Now, C better be bigger than A because it has to be inside the hyperbola. So my foci then are going to be 0, negative 3, and 8, negative 3. The last thing I need to do is write the equation of the asymptotes. And because I've moved my center, it's going to take on the formula y minus k is equal to plus or minus b divided by a, because I have a horizontal transverse axis, times x minus h. So I just plug in what I know. Y plus 3 is equal to plus or minus the square root of 7 divided by 3 times x minus 4. This here is basically the point slope formula. If you want, you can go ahead and rewrite it into slope intercept. There you have it. Now I wanted to share this example with you because they're trying to trick you a little bit. And the reason they're trying to trick you is the order in which they have this equation written. Notice there is a plus here, but there is a minus here. So what you can do is rewrite this, putting the positive fraction first, followed by the negative. And now it's set up in a more familiar way. The minus sign tells us that it's a hyperbola. The y squared being the positive is telling us that we are going to have a vertical transverse axis, which means this hyperbola is going to open up and down. Why don't you pause this and see if you can graph this. So looking at this, remember when we find our center, It's HK, and H is always attached to the X, even if it's written second, and K is with the Y. So I have -1, 4 for my center. Be careful of the signs. So I'm just going to go ahead and sketch this now. So -1, 4 is here-ish. All right, so now A is 5. So because I have a vertical transverse axis, I'm going to go up and down for my vertices. So -1, 4 plus or minus 5 is going to give me my vertices. So from here, up 5, and from here, down 5. So my vertices are -1, 9, and -1, -1. B squared is 4, so B is 2. So from here I'm going to go right 2 and left 2, and this will help me make my box. My asymptotes, sorry, this is going to get kind of messy. My asymptotes are here and here. And when I draw in my branches, they will go, sorry, here and here. All right, C squared is 25 plus 4, which is 29. So C is the square root of 29. So that will put my foci in the middle of these. We also want to find the asymptotes. In this case, it's going to be y minus k is equal to plus or minus a divided by b times x minus h. Plugging in what we know, we have y plus 4 is equal to plus or minus 5 halves times x minus 1. Hopefully that's what you got when you did it on your own. This is a similar problem to what we saw when writing an ellipse in standard form. What I need to do is group the x's, group the y's, and move the constant over and complete the square. When I do that, I have -4x squared minus 40x. Leave a little space, and I have plus 5y squared minus 80y. Leave a little space, subtract 200. Then I'm going to take out the GCF over here, leaving me with x squared plus 10x, because I took out a negative, plus a special little number. Same type of thing with the blue stuff. I'm going to take out a 5, leaving me with y squared minus 16y plus a special little number. Now remember, I'm going to have to add this special number here and this special number to the other side as well. So to find the special little number, I'm going to take b divided by 2 squared, which is 5 divided by, 5 squared, which is 25. Now, just because I write 25 here doesn't mean the 25 goes here. I'm really multiplying this 25 by -4, so I'm really going to have a -100 here. Then over here, I take b divided by 2 squared, which is a -8 squared, which is 64. So that is going to go here. 64 times 5 gives me my number over here, which is 320. Now I'm going to keep this GCF of -4, and all of this factors into something times itself. So it's some quantity squared, and it happens to be x plus 5 squared. Keep the GCF of 5. This also factors into some quantity squared, and it's y minus 8. All of this reduces to 20. Now remember, I want my equation for the hyperbola to equal 1, so I'm going to divide by 20. Everything's divided by 20. And then you reduce these fractions. So my final answer becomes the following. Now, I'm going to kind of skip a step because this is negative, and typically we write the positive first and the negative second. Okay, so my final answer will become y minus 8 quantity squared divided by 4 minus x plus 5 quantity squared divided by 5 is equal to 1. And that's my final answer. All right, we need to get our detective on here. So we want to write an equation. We're given some vertices and the asymptotes. Okay, so let's just sketch what we know real quick. We know the vertices are at 3, 0, and -3, 0, which are here and here. This tells me that I am going to have a horizontal transverse axis because it's going to open right and left. This also tells me that my center must be 0, 0 because it has to be in the middle of those. And it tells me that A is 3. So if A is 3, I have a vertical transverse axis. It's centered at 0, 0. I know a lot of this. In fact, the only thing I don't know yet, because we know this is going to be 3 squared or 9, the only thing I don't know is b squared. Well, I can find that by using the equations of this asymptote. You may recall that this, whenever I have a horizontal transverse axis, is b divided by a. So the square root of 3 is b divided by a. Well, I know a is 3. So this becomes the square root of 3 is equal to b divided by 3. I can get b by itself by multiplying both sides by 3. So 3 root 3 is b, which means if I square this, I have 3 squared, which is 9, times 3, which is 27. So this is 27. So my final equation is x squared divided by 9 minus y squared divided by 27 is equal to 1. Done. All right, now we're going to find the eccentricity. The eccentricity is found the exact same way as that of the ellipse. The only difference here is that the eccentricity is greater than 1. And the bigger the eccentricity gets, the wider the branches become, which is stated here. Okay, the only thing to be cautious of is when dealing with the hyperbola, remember c squared is equal to a squared plus b squared. Here are 2 examples, and you can see the branches are wider here. So this eccentricity over here should be larger than the eccentricity here. So remember, a squared is always first. So this is a squared. So c squared is 15 plus 2, which is 17. So c is the square root of 17. So if the eccentricity is c divided by a, we have the square root of 17 divided by 15. I'm sorry, root 15, because a squared is 15. And then you can simplify this as the square root of 255 divided by 15. This is approximately 1.06458. And you can see that's greater than 1. Over here, c squared is a squared plus b squared. So c is 7. So to find the eccentricity, we take c divided by a, 7 divided by 5 in this case, which is 1.4. That is greater than the eccentricity in the first example, so we will have wider branches. Here we are going to use the eccentricity and the vertices to write the equation. Like always, I'm pretty visual, so I like to sketch a little picture of this. And it's just going to be a sketch here. So I'm going to go left 4 up 1 for one vertex and left 4 up 13 for the other. So if these are my vertices, I can see that my hyperbola opens up and down, which means I'm going to have a vertical transverse axis. This information alone tells me a lot. This is going to tell me my center, which is going to be halfway in between this. So my center is going to be -4, 7. This also helps me identify A. A is going to be 6. All right, so A is 6, which means A squared is 36. All right, so now I'm going to use this eccentricity. So remember, E is C divided by A, which is 5/3 in this case. Now I want to show you this. A common misconception is that C is 5 and A is 3, but we just found A to be 6. Okay, so what I'm going to do is I'm going to plug this in here and then find C. So C divided by 6 is 5/3. I'm going to multiply both sides by 6. And I find that C is 10. All right, well, if I know C and I know A, I can find B by using C squared is A squared plus B squared in this case. C squared is 100, A squared is 36. So I can find that B squared is 64. There's no need to take the square root of this because I'm writing an equation. Because I have a vertical transverse axis, I know that y is first. It's divided by a squared, which is 36. B squared we just found to be 64. Notice once again that B squared is bigger than A squared in this case, which is okay. My center is -4, 7. I want to make sure 4 goes with the x and 7 goes with the y. Be careful of the signs, -7 and +4. There is my equation. Here is an example of an application involving hyperbolas. You may want to pause this, read through it a couple times, and kind of analyze what's going on here. So basically, we have this firework going off, and these two people are a certain distance from the firework. So I'm going to call this distance 1, and I'm going to call this distance 2. And by definition of a hyperbola, d1 minus d2 is going to be 2a. So it's some constant. And another thing I want to mention is that this here is 2 miles. And let's see. So if this is 2 miles and this is 0, 0, I want to convert, because this is in feet, I want to convert miles to feet. You may recall that 1 mile is 5,280 feet. So that means this is 5,280 feet and this is 5,280 feet. All right. Now, I'm going to be kind of using a lot of information here. I also know that distance is equal to rate times time. So the distance is going to be let's see, 1,100 feet per second times 6 seconds. So the seconds cancel, and this is equal to 6,600 feet. This is the distance. Okay, this is the rate, this is the time, so this is the distance. Okay, well, this distance has to be this. So this is going to be my constant. So d1 minus d2 is going to be this 6,600. Which means this is equal to 2a from here. So I'm going to continue with this on the next slide. If 6,600 is equal to 2a, I can divide by 2 and find that a is 3,300. Okay, so let's go on and move to the next slide. Remember that I want to find an equation. And this is centered at the origin, so that's going to be helpful. All right, so we just found A to be 3,300. Okay, now C is 5,280. Okay, that's my foci basically. So if I know A and I know C, I can find B. So 5,280 squared is equal to 3,300 squared, which is plus B squared. Okay, so I'm going to get a big number for B squared. All right, so B squared is equal to 16,988,400. And I can leave that as is, and I can find A squared by squaring this. That gives me 10,890,000. And I can put this into my equation. So I'm going to have x squared divided by, I'm just going to write this as 3,300 squared minus y squared over, let's write this as 4,122 squared, which is this, is equal to 1. There's your final equation, and this concludes section 10.2.